Here we are solving a NEET 22 question in laws of motion basing on momentum and conservation of momentum. The problem says a shell of mass m is rested initially. It explodes into three fragments having masses 2:2:1. If the fragments having equal masses fly off perpendicular with speed v, what is the speed of the third piece or the lighter pieces? It's a standard question that we have seen probably many times in the classroom practices also. There is a mass m. It is exploded into three pieces. Two of them having masses 2:2:2, that is 2 2s and 1. So what we can say is if the total mass is m, that is divided into three pieces. Together they shall have 2 plus 2 plus 1, that is 5 parts. So out of 5 parts, first piece is having 2 parts, second piece is having 2 parts, and third piece is having 1 part. So 2 parts out of 5 parts is 1 piece. Another one is also the same. Third one is 1 part, 1m out of 5 parts. So what he mean to say is this part is having a mass 2m by 5 moving with a velocity v. This part, who is also having the same mass 2m by 5, is having the same velocity in a mutually perpendicular way. That means if this is moving along x-axis, this is moving along y-axis. In which direction the third piece will travel, I will just explain in a second. So the first thing that we need to understand is, as there is no external force acting, momentum is conserved. P initial equal to P final. Initially in the state of rest, so mass, total mass m having a velocity 0. Finally means it was divided into three pieces, P1, P2, P3. Be careful, they are vectors, that's why I can write it like bars. But P1 is perpendicular to P2, so this is P1, 2m by 5 into v. This is P2, that is 2m by 5 into v. So if I have to find out first of all what is that P1 bar plus P2 bar, as they are perpendicular to each other, the resultant will be root of P1 square plus P2 square plus 2P1 P2 cos 90 using the parallelogram law of two vectors, because these two are the vectors. So this becomes root of, both are same of course, P square plus P square, that is root 2 times of momentum of any one, that is root 2 times of momentum of any one is 2m by 5 into v. So I can say P3 bar equal to minus of P1 bar plus P2 bar, where P1 bar plus P2 bar is this way. So if you understand carefully, if this is the direction of P1, this is the direction of P2 and both are equal, the direction of P1 bar plus P2 bar will be exactly in between them. Once that is exactly in between them, P3 bar shall be having the same magnitude but in the opposite direction. So this must be our P3, perpendicular to x and y. That means this must be along z-axis. Be careful with that. So what we can say? That implies P3 bar equal to minus of P1 bar plus P2 bar, that is 2 root 2 m by 5 into v. Minus is to say that it is traveling in opposite direction. So P3 is m3 v3, m3 is m by 5, and velocity v dash we have to find out, minus 2 root 2 m by 5 and v. m by 5's can be cancelled. So v dash equal to minus 2 root 2v. Of course minus is purely symbolic, which is not mentioned in our option, so you cannot choose that minus. 2 root 2v is the thing that we can choose. That's how we solve the problem. So it is purely based on conservation of linear momentum, that if there is no external force acting on a system, initial momentum of the system equal to its final momentum. Thank you for watching.